future scientists. Welcome back to your favorite learning zone, Shubhkaamna Academy. Let me ask you something. Have you ever raised your friend and yelled, I was faster? Or been in a car and felt it suddenly zoom forward? Or wondered why astronauts float but runners don't? Well, guess what? It's all because of motion. So buckle up. Today we are learning about speed, velocity, and acceleration, but in a super fun way. Let's start our motion right. Contents: Introduction to motion, speed, velocity, acceleration, the relationship between the three, summary, and conclusion. Motion simply means change in position over time. If something moves, it's in motion. If it doesn't, it's at rest. You walk from your kitchen to your couch, motion. A bird flying, a train moving, a satellite orbiting. Motion, motion, motion. Fun fact: Earth is moving at about 107,000 km per hour around the sun. Yet we don't feel it. Why? Because it's everything around us moves with Earth. Motion is the change in the position of an object over time, relative to a reference point. It involves various factors including speed, velocity, and acceleration, which helps describe how quickly and in what direction an object is moving. Key concepts. Reference points are crucial in understanding motion as they serve as the stationary background. By establishing a reference point, we can determine speed, velocity, and acceleration, facilitating precise description of an object's motion. Now, talking about speed. Speed is how fast something moves. It's the distance covered in a given amount of time. Formula: speed is equals to distance divided by time. For example, if you run 100 meters in 20 seconds, speed is equals to 100 divided by 20. That is 5 meters per second. Speed is a scalar. It only tells how fast, not the direction. Velocity is just like speed, but with direction. So if you say, I'm running at 5 meters per second towards the north, what's the velocity? Formula: velocity is equals to distance divided by time, but add the direction. Example: a plane flying at 800 km per hour eastward has a velocity of 800 km per hour east. So velocity is a vector. It has both magnitude and direction. Acceleration is the rate at which velocity changes. So if you go from 0 to 100 km per second in 5 seconds, that's acceleration. Formula: acceleration is equals to final velocity minus initial velocity divided by time. Example: you go from 0 km to 20 km per second in 4 seconds. So acceleration would be 20 minus 0 divided by 4. That would be equal to 5 meter per second square. Yes, that's the unit in meters per second. Sounds fancy, right? But it's just speed per second. Real life examples: roller coaster drop, plane takes off, a car braking on or speeding up. So there are two types of acceleration: uniform acceleration, non-uniform. Uniform acceleration occurs when an object's velocity changes at a constant rate over time, whereas non-uniform acceleration occurs when an object's acceleration changes over time. This can happen due to varying forces action on the object, resulting in a fluctuation, speed, and direction. Now, so let's put it all together. What is the relationship between the three? Speed tells us how fast you are going. Velocity tells us how fast and in which direction, whereas acceleration tells us how your velocity is changing. If speed increases, positive acceleration. If speed decreases, negative acceleration, also called deceleration. Imagine this. You are cycling at 10 meter per second east. Then you speed up to 20 meter per second east in 5 seconds. So You have accelerated in the same direction, so velocity and acceleration goes hand in hand. Let's recap our ride through motion land. Motion is movement, a change in position. Speed, how fast you move with no direction. Velocity, speed plus direction. Acceleration, how fast your velocity changes. A pro tip, remember the triangle trick from speed? Mark down. Speed into time. Use it to rearrange and solve these questions quickly. And I'll see you in the next video. Till then, keep exploring and keep learning.